This video begins the last of the material we are going to cover before the final exam. We are going to do 4 sections in Chapter 7, 1 section in Chapter 2, and that's all about conic sections. And then we're going to go pick up 1 section of Chapter 8, which is sort of completely unrelated, not sort of, it is completely unrelated to conic sections, because it is about systems of equations. But first, let's talk about conic sections. So the relative idea of conic sections is that they come from a cone, and these cones are, I don't know, I call this a double cone, but there are 2 distinct lines that intersect at a point. So one line, the axis, which is a vertical line, is fixed, and the other line, which is the generator G, is mobile. So if you want to look on this picture right here, the axis that is fixed goes right down the center. So I just highlighted that in blue. And the generator is what makes the edge of the cone. So we would take the generator, and that goes like this. And if you think they're like fixed right here at the vertex, those 2 lines, so they can't come apart. But if we rotate the green line about this point, it makes the 2 cones. And this is what we call a right circular cone. So the conics are curves that result from the intersection of one of these right circular cones and a plane. And there are 4 conics we're going to talk about. They're circles, ellipses, parabolas, and hyperbolas. So geometrically, here's what happens. If we take our cone and we put the plane through the cone so that it's perpendicular to the axis, meaning that the line of the axis and our plane makes a right angle, then we get a circle. If we put it through at any angle other than a right angle, but so that the plane still goes through the sides of the cone like this, we end up with what we call an ellipse. So, you know, circle is a perfect circle. Ellipse is like an egg. It's oval shaped. Well, that was a terrible oval. But pretend it's oval shaped. So a flattened circle. Then, if we run the plane so that it goes through one side of the cone and out the bottom of the cone, we get a parabola. And remember, these look like this or like this, except now they can also look like this or like this. So now not only could they open up or down, but they can also open left and right. And then if we run the plane so that it passes through both cones and out the bottom of both cones, this is when we end up with a hyperbola. And hyperbolas look like this. So there's 2 lines like this, and the hyperbolas either go like this, or they can go in the other part. So we could have our dotted lines like this, and the hyperbolas can go in this part. And these dotted lines are asymptotes. We've already talked about asymptotes when we talked about the rational function 1 over x. So this is just a very brief how we get these things geometrically using cones and planes. In the next section, we'll talk specifically about circles.